Hello, math students. Welcome to Module 4, Expressions and Equations. This is Lesson 8, and it's called Distributing Expressions. Today, we will practice writing equivalent expressions using the distributive property. That's our goal. The question I want you to think about is, what property do you link GCF to? So whenever you are asked to find the GCF, you should be thinking about a property. And that's what I want you to be able to answer by the end of this lesson. Okay, so things to know. We talked about a little bit in our last lesson what the distributive property means, but now we're actually going to spend the whole lesson talking about it. So distributive property is the property that distributes a factor to all of the terms in the expression. And if you remember from yesterday's lesson, this is called factored form. And this is what the expression looks like when your job is to use the distributive property. So when I give you practice problems and you see this, in your brain, you need to say to yourself, oh, I have to do the distributive property because this is what the expression looks like when you have to do the distributive property. So the way that we use the distributive property to figure out what we have is we like to incorporate the use of tape diagrams. So the thing I want you to remember is the factored number that's sitting out, the GCF. The GCF tells you how many tapes you need. Okay? So for example, in this one, since this says 3, that means I need to draw 3 tapes. So here's my 3 tapes. 1, 2, 3, right? And then inside my tapes, what I have to fill in is what is inside the parentheses. So I have to put 2x's plus 8. So if I draw that, I have 2x's plus 8. All right, that wasn't so hard. 2 plus 8. 2 plus 8. And now what I can do, because I am looking at this tape, and this tape is a visual reminder of me, I can actually see what the answer would be. So I count them. I see 1, 2, 3, 4, 5, 6. I see 6 x's. So I would write 6 x's, and then I have to count up my 8's. So 8 plus 8 is 16, plus 8 more is 24. And so my final simplified answer for factored form, turning it into standard form, would be 6x plus 24. And that is how you guys change factored form, which is what this is right here, turned into standard form. And how do we take factored form and turn it into standard form? We use the distributive property. That is correct. Okay, so down here it asks you to do some practice, okay? And it says, draw a tape diagram of each expression. Okay, well we can totally do that because we are experts at tape diagrams. So here's our tape diagram. You learned this several lessons ago. And this says 2, right? So 1, 2, there's my 2, plus 3. So 1, 2, 3, 1, 2, 3, this is 3. And now I have a tape that represents this expression, 2 plus 3, 2 plus 3. Okay, that was not hard. Now I have to do a tape that represents this one right here. Okay, well, we can do that too because we just looked up above and saw how I did it up there. I have 1x plus 1, 2. So that would be how the tape looks like for showing x plus 2. Okay, so then the next question that I have for you says, what happens if you have 2 copies of each expression? Okay, so what if I had 2 copies of those? Okay, so let's draw this. I have that one, and I also have this one that I'm making right now. Okay, so that doesn't seem to be too difficult, right? Okay, And then what is it? It says what happens if I have 3. Oh, so now I have to do it again. So here's this one. There's 2 plus 3, right? So then, could we write an expression of what we see? Well, we see 1, 2, 3, 4, 5, 6. So our final expression for our whole picture would be 6 plus 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one would be 6 plus 9 if I had 3 copies. If I only had 2 copies, it would be 1, 2, 3, 4, so it would be 4, right? Plus 1, 2, 3, 4, 5, 6. So that would be what that one looks like. Okay, so that's not so horrible, right? Well, now it says, what if I had the same thing of that? Okay, so I am going to draw 2 copies of this. So here we have another one, and this would be x and 2. And what do we see with this one? We see 2 x's plus 1, 2, 3, 4. But if I have a third copy of it, here's an x, here's a 2. Now I see 1, 2, 3 x's plus 2, 4, 6. So that would be my expression for the 3 copies. Okay? So do you see what we're doing when we make additional copies? Absolutely. Okay, so then that leads us back to what would the factored form of this one be? Well, the factored form of this one would be the greatest common factor that we see for this one would be 3. So we pull the 3 out. What is 3x divided by 3? 1x. What is 6 divided by 3? 2. So check it out. What goes inside each one of the tapes is what sits here. How many tapes do you see? 3, and there you have it. Okay? So that's how you link it all together and understand the distributive property. And when you have 3 tapes, that's your GCF. What is inside each one? And x plus 2, because remember 1 times x is the same thing as x, right? So x plus 2, x plus 2, x plus 2, x plus 2, 3 times, because that's what it says. Okay, so going back to our goal, today we will practice writing equivalent expressions using the distributive property, which is what we did. What property do you link the GCF to? The answer to that is the distributive property. So whenever you see the distributive property, you need to think about GCF. Whenever you are asked to find a GCF, you need to think about the distributive property. Okay, kiddos? That's all I have for you today. Talk to you soon. Bye!